Hi students, and welcome to Preliminary Chemistry and the Metals video series. In video number 5 we're looking at some of the reactions involving metals. So there's three important reactions that you need to be aware of as far as the interactions of metals is concerned. The first of these is the reaction between a metal and a dilute acid, the second between metal and water, and finally one that I'm sure you're very familiar with, the reaction of metals with oxygen. Now, each of these are groups of reactions that you would have seen before, but we want to make sure that we get the general equations correct and that we can also write some specific examples of each of these different types of reactions. So the first one we're going to be looking at is the reaction between a metal and a dilute acid. So this would be the general equation. And the general equation is one that tells you what would happen in the general case, and then we can start substituting for specific examples of a certain type of metal and also a certain type of acid. Now, irrespective of the metal or the acid, one of the things that we are going to produce is hydrogen gas. H2 as a gas will be given off in this particular reaction, and we will also produce a salt. Now, the identity of the salt will be based around which type of metal we have and also which type of acid. So let's have a look at a quick example. Magnesium placed into hydrochloric acid. When we place magnesium into hydrochloric acid, we get our hydrogen gas. The salt is formed from the magnesium and what is left of the acid once we remove the hydrogen. So that is chlorine in the case of hydrochloric acid. So that means our salt in this case would be magnesium chloride. You may need a periodic table to ensure that you have the correct organization for the formulas, but I've given you the first two. Here they are. Mg is magnesium, straight from the periodic table. HCl is the way we represent hydrochloric acid. So then we have H2 gas, and then we also have our salt, which is magnesium chloride. Now, in order to make sure that we have the formula correct, we need to look at the valencies of both of these two species. We can do this very simply with the periodic table because we look at magnesium being in group 2, so it will have a valency of +2, and chlorine is in group 7 or 17, and it has a valency therefore of -1. It's only one away from the noble gases. And what that means is that we need 2 of the chlorines in order to balance the magnesium, and hence the formula will be MgCl2. Now we must do that first before we try and balance the equation, because we have to get each of these species correct. Hydrogen gas has the form of H2, not H, not H4 or 3, H2. Likewise, the formula for magnesium chloride is MgCl2. Once we have that, then we can balance the equation. And if I just change the color for a moment and pop a 2 in front of the hydrochloric acid, then you'll see we have one magnesium on each side. We have 2 lots of hydrogen and H2 here, and we have 2 lots of the chlorine and the Cl2 here. So now our equation is balanced. The next example we want to have a look at is metal plus water. Now, one of the important things about metal plus water reaction is that it's really an example of a super dilute acid, because we still get hydrogen gas as our product, but what we get is a salt, which is actually what is left over from water when we take hydrogen ions out of it. So water could be written as HOH instead of H2O, which means when we remove this hydrogen, we get left with the OH group, which is what is going to bind to the metal to form the compound that we have, which is our salt in this case, our metal hydroxide. So again, let's look at a specific example, magnesium plus water in this case. Now, this is going to be a very slow reaction. Maybe a little bit of heat might help this to occur. But if we could get this to go, then the magnesium would produce hydrogen gas when combined with water, and also magnesium hydroxide. So the hydrogen gas is here, and in this case, we've got magnesium, which is our metal, and hydroxide is obviously the name that we give to this section here. Now, as with the previous example, we want to make sure we can get the balance right. So I've already started this in the step above. Here's the H2 gas, and we need to know something about the hydroxides. Now, we've already determined that the magnesium is 2+. Hydroxide is one of these ions that has a -1 charge. There are some ways of working that out, but at this stage it's easier if you just accept that that's the case, which means the formula is going to be MgOH2 in order to balance it. -1 charge for the OH, so we need 2 of these in order for that to happen. Then once again, we have to balance the equation. In this case, we've actually got 2 and 2 is 4, so I'm going to put a 2 in front of this and see how we go. So now I have 1 magnesium and 1 magnesium. 2 2s are 4, so I have 2 and 2 here, which is 4. And then the 2 oxygens, and I have my 2 oxygens here as well, because this number is multiplying everything in the brackets. So that's my second equation. My final reaction is metal and oxygen. And this is a very, very simple one, and one we've done a lot whenever you've burnt magnesium. Beautiful glowing light, and that combines with oxygen to form magnesium oxide. And that's an example of this type of reaction, a metal plus an oxide forming a metallic oxide. We probably don't need to spend as much time on this one. Obviously, magnesium plus oxygen will give us magnesium oxide. And once again, we can write an equation for this. So Mg plus O2. In this case, once again, we need to have a look at our formulas. We now know magnesium, because we've used it in the other examples, is +2. Now oxygen is going to be -2 because it's in the sixth group or the 16th group, and it's 2 away from the nearest noble gas. So it's a -2, which actually means this formula is correct. The 2 balance each other out. So when we go to write the balancing for this equation, because of the 2 that's here, I'm going to have to put a 2 here. So then I've got 2 oxygens and 2 oxygens, but I've also got 2 magnesiums, so I'm also going to have to put a 2 out the front here. And now my equation is balanced. Have a look at these. We'll do some more examples in class, but these are the 3 critical reactions involving metals that you should be expected to know. Thanks for watching.